All right, great. Well, thank you. So what I'm going to be talking about next is the structural modeling capabilities and FEA mesh export capabilities available in OpenVSP. So this was done as part of a SBIR effort funded by the Air Force Research Lab, which is also funding OpenVSP. So this was done a few years back. It's had some minor changes and updates since then. Are still more improvements that may come, but this is just what you can do in OpenVSP. I'll walk through the just basic concepts of the terminology that we use, what sort of capabilities that we have in OpenVSP, the implementation approach. Then we'll go through the typical workflow. We'll walk through the GUI, all the different FEA part types, which are structural entities, just another word that we call them. We'll do an example analysis. I'll talk about the CAD exports. So that's been something that's been updated more recently through our latest funding effort. I'll briefly talk about API and scripting. More details on that, you could see the previous presentation I did. And then I'll walk through a demo. Please use the YouTube live chat stream to ask any questions that you guys have, or if you'd like to see anything in particular, or use the conference.io link that's on there as well. So when we initially set out to add this capability to OpenVSP, we wanted to just support modeling of aerospace structures and FEA mesh generation. This was actually something that there was a capability for in version 2, but we wanted to bring it to version 3 because it had been left behind and just improve it from there. The features that we have available, we have parametric modeling of fold depth structural members. So that means things like ribs and spars that go all the way through the OML. You can use subsurfaces to model different areas of your structure. We have beam and shell elements. Those are the two FEA elements that we support. We have key point identification, so that, which I'll describe more in detail later, places a node at a specific point on the surface that you would like it to, and that can be used for attachment points, point masses, things like that. We have exports to Nastran, Abacus, or Calculus in GMesh in these FEA mesh formats, but also you can export STEP and IGES if you want the analytical surfaces. So like I mentioned earlier, there were some capabilities for structural modeling in version 2. You could only have, excuse me, you could only have one structure per vehicle. It only worked for wings with ribs and spars, and you only had shell elements. There wasn't any material property assignment, anything like that. You also couldn't include point masses in your mesh. So in version 3, we've brought all of that capability to start and then improved it, like I said. So we have multiple structures for multiple geometries. So a single wing could have dozens of structural models associated with it, and you can pick and choose which one you want to export. We don't only support wings. You can have, like you see at the bottom right there, a fuselage. We have a variety of FEA part types. So instead of just ribs and spars, we have bulkheads, or dome as we call it, just generic slices. We have subsurfaces, fixed points, things like that. Instead of just shell elements, which are the triangulated surface elements, we have beam elements too, which are border curves, intersections, things like that. Subsurface edges, things like that. We have a complete materials and properties library, so you can add your own materials and properties and assign your shell or beam elements to those properties. And then we have tools for visualizing the mesh. And then, like I said too, we have a point mass as a fixed node in your mesh, wherever you specify. So the structural entities that we support, we have full depth entities. So those are ones that pass completely through the OML. Examples are ribs, spars, floor, bulkhead, things like that. And those are a shell type of structure. We then have zero depth. So those are things like stringers, stiffeners, longerons. They have cross-sectional properties associated with them. And they take the form of subsurface edges or intersection curves, and they're represented as beam types. So we have shell and beam types, and then we also have key points. So a key point is going to be a corner of the triangulated mesh, so where the corners come together at a specific point that you specify. This is used to provide connectivity to other structures, which is really important considering that we can only have a single structure on a single geometry at a time. So you can't have a structural model of your wing and fuselage. You have to have one of your wing and then your fuselage separately. These key points allow you to potentially connect those together in separate tools. We don't support partial depth structures for the most part. There is some limited capabilities in terms of having ribs and spars that are only confined to a certain section of your wing, things like that. But for the most part, we don't support partial depth structures. Those sort of things are going to be like an open frame, a stiffener that doesn't go all the way around the OML, things like that. So this is identifying some of the terminology that we use in OpenVSP. So to start off, we have a structure or an FEA structure. That is a collection of FEA parts. As I mentioned, you could only have one structure. Each structure can only have one parent geometry, but you can have more than one structure for a given geometry. An FEA part, those are structural entities. Those are things like ribs, spars, everything like that. Even subsurfaces, those are all structural entities or FEA parts. It includes the full depth, no depth structures, and key points. FEA elements are those connections of nodes. So when you triangulate the mesh, every triangle is an FEA element. Each corner is an FEA node. So those are used to build up the elements. Nodes are assigned to multiple elements. And so a node might be adjacent to multiple triangular elements. And then we have shell elements, which are the triangulated surface elements. Those are going to be full depth. And in Nastran, that's the C-6 type, or in Abacus and Calculus, that's the S6 type. So 6-node triangular elements. So we also include, if you see on the right here, we also include the midpoint of each segment of the triangle as part of that 6-node element. Beam elements are going to be the zero depth elements. So we also call them caps. Those are going to be the C beam type in Nastran, or in Abacus, the B32 type. The right image gives you kind of overview of these different this different terminology that we use in OpenVSP. So here's the typical workflow, and I'll walk through the GUI that follows this. So you first have to have a geom. You then go to Analysis and FEA Mesh. You add a structure to that geom or any other geom that you have. There are optional settings, so you can add up or create your materials library, and you could also create a library of properties and assign materials to each properties. The mesh settings can be adjusted, and your output files can be specified. But you can also just go with the defaults. Then once you have your structure, you can add FEA parts to it, modify their parameters, and then once you're all ready, your structural model is complete, you click Mesh and Export, or which I didn't mention on here, you can click the Export CAD button. Then you can visualize the results, the intersection curves, things like that, the triangular elements, and then you can take those exported files, your step and IGES file, your Nastran file, things like that, and import them into any of these external tools that we support. So jumping into the FEA Mesh GUI, this is showing the first tab. So at the very top, we have a link to the wiki documentation, so easy to access there for new users. We then specify the unit system, and that just makes sure it basically just is the what's written out to the file, the export files. It keeps everything consistent. When you change your unit system here, it'll automatically update your materials and property settings to it'll convert those automatically. So that's what that's used for. We have a browser that lists all of our structures, but the first thing we have to do is add a structure for it to show up there. You can specify which geom you'd like to add a structure to, and you could add a structure to anything that has a surface. So you can't add it to a blank, but you can add it to an ellipsoid, body of revolution, whatever else you like. I don't believe you can add it to a mesh geom either. Pretty sure about that. So the surface selection is if you have a component with multiple surfaces, so that that surface index is for main surfaces. So if you have a propeller, the default propeller is 3-bladed, you could add a structure to any one of those blades. You can't add a structure to the entire 3-bladed propeller. If you have structures in this browser, you can click on them, and that'll update at the bottom what your current structure is. If you also have one selected, you can click delete to remove it. For body components, and this is what's shown when you have one selected, you can basically just show the dgen geom preview. So top, front, top, side view, those are those options there. For a wing geom, we just have a top view, so that's going to show a top-down view of the dgen geom preview. If you'd like to get back to your regular 3D view, there's options in the geom browser to go back to that. I can point those out later. Going to the part tab, this is where you're going to be adding structural entities to your FEA structure. So this will, when you first add a structure, all this will have is the skin on the top line. So that's the outer mold line. That one, you can, the only option that it has is to remove the skin tries. So, or remove the skin on export. So that would just leave, if you have a wing with ribs and spars, it'll remove the OML from your export. That's really the only setting you can change on it, other than its property that's associated with it. Next, what's going to be listed in that FEA part selection browser are your just standard FEA parts, like which I'll go through in a little bit, which does not include subsurface types. So ribs, spars, slice, dome, things like that. Those will all be listed next. Below that, you'll have subsurface types. There's options to reorder things in that browser. Primarily, that comes into play for subsurface types only. And what that does is when you have overlapping subsurfaces, the order that they appear in this browser will dictate how elements are assigned to the overlapping sections. So that's what that's used for. In the middle, we have the type of FEA part that we'd like to add to this browser. Once you add it, it'll pop up a new window with parameters to edit things. If you close that or want to select a different one, you could also select it and click the Edit Part button. You can delete any part that you have selected. You can also use the Shift and Control keys to highlight multiple parts at the same time, and you could delete multiple at the same time. I believe you can only edit the name of a single one at a time, but that's what this next entry is for, changing the names of your FEA parts. Under General, which you can do with multiple at the same time. You can set it to a shell, a cap, or a shell and cap. So if it's a shell, we're going to have the triangular elements saved in the mesh. If it's a cap, we're just going to have the intersection curve saved. Shell and cap will have beam elements along the intersection curve or the subsurface edge, and we'll have the shell elements that make up the actual surface. You can assign properties to your shell and cap elements there, and then you can show or hide the FEA parts from the 3D view. So the first FEA part type that we have, which is sort of the basis for some of the other ones like ribs and spars, is the slice type. So on the left here, we have the GUI that's associated with that specific FEA part type. So you can change its orientation. We have a few options there of how you'd like it to be oriented. You set the distance as relative or absolute, relative along the axis that you specify under orientation. Rotation axis you can specify as well. You could just do a single rotation at a time. And then at the bottom, this is pretty much standard for every different FEA part type. You can specify the elements that you want to include and their properties that are associated with them. So next we have wings and spars, which are only available, ribs and spars that are only available for wing type geometries. So the rib's going to be defined from the leading edge to trailing edge automatically. It's just both of these are based off of the slice type, but they're just parameterized in a way that makes a little bit more sense for ribs and spar type modeling. For ribs, you can specify, and this has been slightly updated since this image was put in here, but you can specify if you want to be the rib to be normal to the leading edge of the wing, the trailing edge of the wing, or any other FEA spars that you added as well. So if you have a leading edge spar or a trailing edge spar, you can set your ribs to be perpendicular to either one of those. Limiting rib to section and also limiting spar to section. That means that you want that FEA part to only be in a section of the wing if you have a multi-section wing. If it's placed along the edge of that section, it'll be automatically trimmed. So I'll give an example of this, but one way you can use this for is if you have a multi-section wing, you can place one spar in the first section at one location, and then place another spar in the second section at the same location, and those will be at a different angle if you have changes in your wing sweep or anything like that, but they'll still be connected at that change in the wing section. I'll demonstrate that and explain it more a little bit later. For both of these types, you can specify the distance as relative or absolute. You can specify a rotation. So this is going to be just a rotation about, I believe, the z-axis for a wing. So one limitation here that we have at the moment is I've changed my internet that I have selected. Hopefully it's a little bit better this time. Do you know which slide I was on before
You were on this slide.
I was on this slide. Okay, good. Okay. So sorry about that, everyone who's been listening in. Hopefully that doesn't happen again. But going back to this presentation on FEA structural modeling in OpenVSP, the FEA part for rib and spar, you have some capabilities to limit it to a certain section, if you like, of your wing. You have some capabilities to change its rotation. One limitation is if you have dihedral in your wing, you don't have the ability to really line up your rib with your dihedral. That's something that could be improved in the future. There is a workaround, and I'll explain that a little bit later. But this trim to bounding box option, you can select that if you'd like to trim the FEA part just to the leading and trailing edge of the wing. Otherwise, it'll trim it to the entire bounding box of your wing. That's mostly used if you have some weird things going on where you have a really sharp change in angle between two ribs. and they are extending out, and you want to avoid that intersection, things like that. Most of the time, you could just leave it on by default. XYZ location and an XYZ rotation. You can attach it to the spine of your component. It's only used for body type components, so you can't have it on a wing. And you just basically oversize it. It'll intersect and leave what you can see there in that image behind. So fixed points are next. So this one's really cool. You can specify in UW coordinates a particular place on a surface that you would like the mesh to hold. So triangles will be connected to that node. That node won't be in the middle of a triangle if it's all done correctly. You could also specify the parent surface, so it's going to default just to your OML, but you could also put it, if you'd like, you could put it on a rib, a spar, anything else you'd like. You could also assign that element, that point mass, and that'll be written out to the file as well, using the unit system that you specify on the first tab of the GUI. So then we have subsurfaces. So all the subsurface types that you have for normal geometries, not for structural modeling, those are also available for structural modeling. So we have the line, the rectangle, and the ellipse. Those are available for every geom type. Control surfaces are only available for wing types, but same sort of parameterization as how you would model subsurfaces normally. So example for the rectangle, the ellipse that's shown here in the middle, you have your center U and W, you have your U and W length. If anyone needs clarification about how U and W works, please feel free to ask, but it's that 2D parameterization that we use throughout OpenVSP. One thing to note here is there's an option to do cap and no tries. What that is going to do is only keep the edges of your subsurface and delete everything that is actually the triangles associated with that subsurface. So this allows you to do things like punch a hole in the side of your OML, other things like that, make an access panel, anything else that you'd like to do. So that's what that option is there for. The next FEA part type that we have available are array types. So this just allows you to add a lot of ribs, slices, or line type subsurfaces all at once using a fixed spacing, anything like that. You could have the distance in relative. That would be a fixed number of parts in that array. Or you can keep the distance as absolute, and that'll keep the spacing between the parts constant. So that's what those capabilities are there for. You can click an individualize button for all these different array types, and that'll take your rib array, convert it into a bunch of individual ribs. You can't go back from a bunch of ribs to a rib array, though. Next tab we have is the materials tab. And so the materials in the properties tab, those are available for all structures, so you don't have to have a structure selected. It's just a library that you can then, once you have a structure with FEA parts, you can assign these materials and properties to any that you like. You don't have to create a new material library for every structure that you add. So that's what this is here. We have just a couple of example default ones, but you could just click the Add Material button. They're specified by their mass density, elastic modulus, Poisson ratio, and the thermal expansion coefficient. Like I mentioned earlier, the units on these are going to be converted just however you set your unit system on the structure tab. Properties, each one of these properties is going to be assigned a material from that previous tab. So you could have beam type or shell type properties. Those are going to correspond to shell type elements, your triangle elements, or your cap or beam type elements, which are your intersection curves and your subsurface edges. Shell property, all it has is a thickness associated with it and the material, of course. Beam properties, we have a couple of different options. You could do a general cross-section type, so that's going to be specified by its area, moment, and products of inertia, or we have some standard types of circle, pipe, rectangle, box, things like that. There's a little show XSEC button here. If you click on that, it'll identify which dimensions we're talking about when we just list out dim1, dim2, dim3 as parameters. So that's what that'll show you. Next one here is the Mesh tab of the FEA Mesh GUI. These options are identical to the mesh settings for CFD Mesh. So if you like details about those, there's some good documentation on the wiki, but also feel free to ask as well. These mesh settings are specific to each structure. Be careful if you're working in a different scale of your model than what the default size of the wing is in OpenVSP, things like that. You'll probably want to adjust your mesh settings. So if it's taking forever to run and you haven't adjusted your mesh settings, it might be because your model is very large and your triangles are extremely small. So try to avoid things like that. Test along the way and try to make sure your mesh resolution is close to what you want. You could always start coarse. It'll go a lot faster, and then refine it as you go. There's a half mesh option there. So if you have symmetry, this should make it go about take half as long to execute. There was a bug that was fixed recently in the half mesh option. So this fixed a few versions ago. It should now actually be faster than a full mesh. So that's what that is there. On the output tab, we have a whole list of different output files. So at the top, those are the ones that are specific to the mesh. So we have STL mesh, which is for like Gmesh. Those don't contain the material or property information, but they are mesh files. We have a mass file. So I guess this one's actually not a mesh file, but the mesh information is used along with your material and property information to try to calculate the mass of your tri and beam elements and your total mass there. That's what's shown on the bottom right here. We then have the nastran and the associated nkey file, which allows the nodes and elements to be tagged and identified. Then we have the calculix or abacus file format. Surfaces and intersection curves, we have a few file formats for. And then at the bottom, which is the most recent addition, we have the trimmed CAD options. So the first one on there, you can just list the information that you want written out to those CAD files just to identify things a little bit better. Those get written to the various layers of the CAD export file formats. You specify your length unit. That's just going to be something that's written out to the file. Then we have IGES and step options. We have some more options for the step file. We have a tolerance that just gets written out to the file. That's supposed to, just tell the file that you're importing it to when to consider points that are close together as the same point. I believe that's what that's used for. We then have a shell representation or a brep solid representation. Last, for the GUI tabs, we have the display tab. So this is going to be available after you've actually generated a mesh. It allows you to visualize the triangle elements, the cap elements, things like that. So we have a draw mesh, color elements, draw nodes, draw element orientation vectors. So this will show a vector that identifies how each triangle is oriented. So this is going to be used for things like composite layups and things like that, I believe. We color everything differently so you can identify them. You can't change those colors. There's no user control for that, unfortunately, at the moment. But in the display element set, you can show or hide any of your sets of elements. So you can hide the OML, you can hide a certain spar, things like that. We then have intersection curve display information. So this is really important if especially for trimmed CAD exports. If it doesn't work for some reason, you could come in here and try to take a closer look at some of those intersection curves and see if something went wrong. Things to look out for are, jagged intersection curves, gaps in your intersection curves, things like that. If that does happen, you might just need to adjust your geometry slightly, move the location of an FEA element, or excuse me, FEA part, things like that. If you do have mesh issues, that's kind of the approach that I would suggest. Just, move things slightly so it doesn't really change the overall design, but helps alleviate these mesh resolution issues. So here's just an example of an analysis that was done. So created a structure in OpenVSP, exported it as an FEA mesh. Here we're showing the visualize nodes option, and I used the clipping tool to have a little bit of a view of what's inside along with the OML. We then imported that to Calculix, did a really simple, setup of the load condition or the load nodes and the boundary condition. The primary purpose of this was not really to, assess the results of the analysis, mostly to just check, when we apply a boundary and load condition, does the mesh stay together as we expect it to? Do we have that correct connectivity there? If you could see here with these exaggerated deflections and displacements, we do keep everything together. I wouldn't focus too much on the values of the results that you're looking at. This was just done to prove, yes, we have the connectivity that we expect. And so you should be able to use this tool for, a more detailed analysis if you'd like. So the next thing I'm going to talk about is two of the, or at least one of the newer additions, two different ways to do it. So we have CAD exports available. You can do untrimmed CAD exports, which is going to give you something like what you see on the bottom right. So when you're adding FEA parts and you see them in the 3D view, those are just cutting planes, and when you export them as untrimmed, they're not going to be trimmed against the surface or anything like that. They're just going to be exactly how you would see it in the 3D geometry view. They're not intersected with the OML or anything like that, but it does at least get you the representation of where you put these different cutting planes and things like that. More recently, we've added trimmed CAD exports, and so this will take that representation that we saw earlier, intersect everything, and only leave what's inside the OML. There are some limitations. It does not actually split the surface where those the parent surface where those FEA parts are placed. That might be something that we'll work on improving in the future, but at the moment, this is how it's done. Subsurfaces, those are just exported as surface curves, so the surface isn't broken with where you place your FEA subsurfaces as well. And intersections between FEA parts, like, I'm not sure if you guys can see my mouse, but something like this where we have the spar intersecting the rib. This is not breaking up the rib into a leading edge surface, a middle surface, and a trailing edge surface. It's still a single surface, and we just identify this intersection curve as a surface curve in the export files. Other things that, these are all things that you might be able to do to improve the tool, but at the moment, this is just what to expect. Main purpose of this is to be able to, use external meshing tool to generate your desired mesh. So if you want a quad dominant mesh, this will be the approach that you need to take right now. A couple of bugs to be aware of. Sometimes if you have parts that are coplanar, what we try to do is check for those and merge them to avoid issues with the mesh algorithms just crashing because it can't determine an intersection, or at least a single intersection curve between two coplanar parts. But the problem is if you have something like a spar that you have limited to your inboard section and your outboard section, but they're still on the same plane, it will try to merge those, and it'll turn them into a single FEA part instead of having one just for the inboard section and another one for the outboard section. So that's something to be aware of. There are some issues with the trimmed CAD export with having the FEA parts confined to a certain section, or for when symmetry is on. So if you look back at an image like this, all these cutting planes are oversized slightly. And so when you have something like a spar, it's actually going to be oversized into the symmetric copy. And if you have it limited to a certain wing section, it'll be slightly oversized into the next section. When we triangulate it, we just get rid of those triangles that are outside of that. But this leads to problems when we're doing trimmed CAD exports where we're not really throwing away those surfaces correctly. So that's something to be aware of. It'll work really well for if you have turn symmetry off and if you just have your spar not confined to a certain section. So just some things to note, but we'll be working on improving those. A couple of improvements, I mentioned a few of them on the previous slide. There have been a few other suggestions that I've been told of. So an option to set a rib on the total or sectional root and tip. Right now you have to do it manually, and if you are going to put a rib on your wing root or tip cap, make sure you turn the caps off first. Otherwise that'll lead to potentially a coplanar intersection issue. If you have rounded tip caps, that's a little bit different, but if you have flat tip caps, that will be an issue. So turn them off if they're flat and you're placing a rib there. Like I said, we talked about improving some of the trimming algorithms for these different FEA parts. And then I also mentioned earlier the issue with ribs rotating them when you have a dihedral or anhedral. Right now, you'll just have to use a rib type to model them instead. Or excuse me, a slice type, I meant. And then the last thing I had here is just a list of the API functions along with where to find them in the API documentation. There are two examples you can look at. One of them in C++ is the API test suite. There's an FEA mesh test in there. We're working on developing a more complete test suite for FEA mesh. Then in the scripts directory, there's a FEA mesh VSP script you could take a look at. And like I said, there's an analysis in process or test suite in process, and there's also an analysis in process. So instead of using these functions, the API functions specifically for FEA mesh, you'll be able to use the analysis manager. So we'll have a string associated with this FEA mesh analysis, and you'll be able to run it through that way. Any questions before I go through a little demo?
Yeah, we've had a handful of questions here online, and we've been answering them live as best we can. We just had one asking how the mass of the tries can be calculated if the thickness of the shell, say the rib, spar, the skin, isn't necessarily specified. Is that more up to the FEA tool?
So we do calculate it in OpenVSP because you assign a thickness to your property, your shell property. I could just pull that up in the GUI to show you. But if we go to FEA mesh and we look at the shell property, it has a thickness associated with it. So yes, it's a shell element that has no thickness, but since we're assigning it this property, we can calculate a mass using the material that's associated with this property as well.
Thank you.
Yeah, you're welcome. Well, all right, well, I'll go ahead and start off with the demo here. So I will add a wing structure. What I'm going to do is I'm going to break it into two sections. And feel free to interrupt me at any time if there are any questions. I'm going to go to Analysis, FEA Mesh. From here, on the Structures tab, I'm going to add a structure to that wing. And then I could click this Orient Wing button. That'll show the dgen geom preview from top down. If you want to change back, you could go select the geom, go to normal, and go back to wire. I'll leave it in that dgen geom preview for now. Here's where you select your different unit system. I'll leave it just as is. Next, I could start adding FEA parts. So the first one here is the skin. As I mentioned earlier, it just has this remove skin tries option. I'll go ahead and start off adding some spars. So this one, I could call it, just clicked on edit part to pull up the parameters. You could also double click and that'll pull up the parameters for it too. I'm gonna call this the trailing edge spar, and it'll be the inboard one because we have a 2-section wing. So after naming it, I'm gonna click this limit spar to section option and see how it will just confine it to the first section. I could have it for 2 sections. If you have a 5-section wing, you could have it even just between 2 of those sections or 3. But I'm going to have this just on the first section for now, and I'll put it somewhere like 0.75. Next, I'm going to add the outboard trailing edge spar. So I'll add another spar. It'll, whichever one I have selected, it'll update the FEA part edit GUI to correspond to it. I'll call this one trailing edge spar out. I'll limit it to the second section. One thing to note is if you try clicking here, it won't let you have the first section be greater than the end section. This is something especially that's come up when you're modifying things through the API. You have to update the end section first before you can update the start section. And I'll make that at 0.75 as well. So now you can see I have 2 different spars, one for the inboard, one for the outboard section, but they'll be connected at this this break in the wing section. For the leading edge spar, I'll just keep that one as a single, across all sections. And I'll put that at something like 0.25. Now what I'm going to do is add a rib array. Similar, I could do this one just for demonstration. I'll have it in the first section, and then another rib array for the second section. This one I'll decrease the spacing a little bit. Whoops, increase the spacing, I meant. Something like that. I'll look at the top view again. There we go. I'll call this rib array in. The next rib array I'm going to add will be the outboard one. So a lot of what I'm doing is just for demonstration, not necessarily representative of any wing structure that you'll be modeling. But this one I'll have just on the second section. In here, one thing I could do is I could say leading edge to be perpendicular to, the trailing edge to be perpendicular to, or I can pick any of these spars that I've added. So I'll just have it to the trailing edge for demonstration. Things like material properties, things like that, I'm not going to worry too much about them right now. I could always go back and update them later. What I'm going to do next is I'm going to add some fixed points in this area, maybe on the bottom wing surface, show kind of like a attachment point, something like that. So if I go to fixed point and add, so that's going to be moved in UW coordinates. So I'll have to move it out first, and then it'll wrap around the bottom. And I'll just place it somewhere like there. I'll just place another one real quick just so you guys can see the results. Maybe something like that. So I have 2 fixed points on the bottom of the wing there. Maybe it'll be attaching something like an engine. I don't know. But that's what that'll be. You can also, like I said, change if you want it to be on any of your FEA parts. Another one I could show is, real quick, how about let's add a rectangle subsurface. So just the regular subsurface modeling capabilities that you have with other geoms. And then I'm going to show you this cap no tries option. So maybe this will, model like an access panel. And we're going to just have basically a hole that's punched in the top of this wing. Make it a little bit smaller, maybe. Yeah, something like that. Okay, so there's the quick demonstration of a representative wing model, or not so representative wing model. Not sure, but that's what we have here. Then just briefly, I can show you the materials property tab. I could add a new one if I like. If I had a specific material I'm trying to model, I'm just going to use the defaults that are available here. And then on the properties tab, I could change this. If I want to make the skin a little bit less thick, or I could add a completely new one. Same with the default beam elements. Going back to the parts tab, right now we have just the kind of default settings for the shell or cap properties or assignments and the associated properties. You can't assign a cap property when you don't have either cap or shell and cap selected. But one thing that's really neat about this is you can select multiple at the same time. And even if you have one like a fixed point that can't have a shell or cap property associated with it, I could still go ahead and select multiple at the same time. That'll update here. I can assign a cap property or a beam property to all of them, things like that. So that's what you could do in this part tab instead of having to open up each one individually and change that. For the rectangle, I'm going to change that back to cap. So this is going to remove the interior triangular elements. I'll leave the mesh settings the same, just since I'm working in the the kind of the default scale of everything. Output files, I'll turn these ones off for now. I'll demonstrate a separate trimmed CAD export. I'll just leave the mesh files for now. And then display, this will populate once I click the mesh and export button. Just for the sake of time, I'm going to turn symmetry off, and that should get rid of all the FEA structures on that side, and this will run a little bit faster now. I could have also just clicked the half mesh button. Same thing. So mesh and export should go pretty quickly.
Hey Justin, while that's working, someone asked on the social Q&A if you can have multiple beam properties set to different beam elements. So if you can have, can you make your own properties out of different thicknesses and materials and apply those to different elements?
Yes, you can make your own properties. Like if I just came in here, select beam property, click add, I could change the material. I could change the cross-section type, change its width and height, and I could assign that to, an individual rib cap. I can make a line array and assign those elements there. That's what you could do. But you can't assign maybe like part of the rib cap as one property and part of the rib cap as another. Hopefully that explains it. But here we see the result from the mesh. Have a couple of pretty thin triangles, things like that. I might want to adjust my mesh settings to solve that. But everything's connected at least. We could go to the display tab and hide the skin if we like. I can also show you here, we have where I said cap and no tries, we have a hole basically punched in the top of the wing. You can still see the ribs on the inside though. And also that the cap from those ribs was not actually removed from the inside of that as well. So that's what that capability is. if I go to the bottom of the wing where I put those fixed points, you'll see they are nodes at the in the mesh. So that worked correctly. The mesh fixed those as we intended. The spar that I had as a 2-section spar, if I turn off the skin, that should be connected correctly as well. So yeah, there we have it. Just a quick example. It's definitely limited in some ways, but it's definitely could give you a good starting point before you move on to more advanced tools. And if you do need some of the more advanced tools, that's what M4 is going to be talking about next with their Structure Studio. So this is what you could do within OpenVSP, just using the built-in capabilities. But
Justin, would you demo taking that to CAD real quick?
Yeah, so this one I'm going to pull up a different model, just because this one had that, or I could at least just change it real quick. But remember how I mentioned that issue when we have spars that are on one section and another?
As long as it doesn't crash, I'd say show it with the issue. It'll help explain the issue.
Okay, I mean it won't. The step file probably won't open, but I could still export it.
Then go ahead and show one without it.
Okay. Yeah, usually the Aegis file might open correctly. Those usually have better luck. But what I'm going to do is just change the spars. Let me show those. I'm just going to change this one to be a full to go across the full span, and I'm going to delete the other one. Let me show the wing. There we go. So I could go to the display settings and click reset display if I like. That'll get me back to where I started when I was editing those FEA parts. So this one should be, I think I accidentally deleted the wrong one. I'll move this one back to be the leading edge bar. Don't worry about the name conventions at the moment. And this one should be also across the full span. I'm going to delete the rectangle as well. I'll hold off on that one, but I'll go to export CAD. Actually, let me change the output files first, and I'll go through export CAD, which you can also do mesh and export if you have these selected, but this will just skip the mesh triangulation if you are just going straight to CAD. I'd look in the terminal that pops up. There could be some error messages. Looks like we're okay for the most part. The one thing that I'd be concerned about if I'm exporting to Stepper Aegis is if you see any error message that's like a failure to close loop, things like that. I'll pull up FreeCAD. This is using Open Cascade, so it should have similar behavior as a couple of other open source CAD programs out there. Go ahead and find that step file. Yep, that's the one. Should be the same as the Aegis as well. But if all went well, should have everything trimmed correctly. Let me turn the transparency up. So there you can see everything's been trimmed against the OML. We might have some issues if you zoom in closely on some programs. Sometimes, since the wing surface is not broken up by these ribs as well, the ribs aren't really fully connected to the wing surface, so that is a limitation. Hopefully we'll be able to improve it soon. But that's just something to be aware of. Some programs might have better experience with it than others, but by all means, please let us know if you do use this capability. Let us know how it works for you. Very happy to hear about it, and know if there's anything we can improve. So probably just about low on time now, so if there are any questions, please feel free to ask. I don't know if there was anything API related that was asked earlier that you guys might want me to answer.
Considering we only have about 3 minutes to get M4 spooled up, you can continue answering some of the questions in the live chat or the social Q&A. But I think we'll you know, I'll just go ahead and say that, really appreciate you taking the time to demonstrate those features. FEA mesh is just one of those really cool things in VSP that they should be really proud of, because it's exceptionally useful and versatile. So